Okay, let's just jump right into it. When you look up at the night sky, everything you can possibly see, the stars, the planets, all those galaxies, that makes up less than a fifth of all the actual stuff in the universe. The vast, vast majority is totally invisible, completely mysterious, and it's the cosmic glue holding everything together. Welcome to the very strange world of dark matter.
So let's start with what sounds like a pretty simple question. But believe me, the answer is one of the biggest puzzles in all of science. If you could somehow gather up every single bit of matter in the cosmos, what would most of it actually be?
Well, the answer is something we can't see at all. Take a look at this pie chart. It's kind of like the recipe for our universe. All the normal matter, the stuff we know and love, that's you, me, the Earth, the Sun, it's just that tiny little sliver. About 84% of all the matter out there is something else entirely. We call it dark matter. And no, not because it's evil or anything, but because it doesn't interact with light. It's just dark.
So you're probably asking, how in the world do we know something's there if we can't see it? Well, it's because we can see its effects. And to do that, we have to go to what is essentially a cosmic crime scene, a spinning spiral galaxy. This is where the first real clues started popping up.
The key piece of evidence that astronomers use here is a tool called a rotation curve. Honestly, you can just think of it as a galactic speedometer. All it does is plot how fast stars are moving versus how far they are from the center of their galaxy. A really simple measurement, it turns out, that led to a completely revolutionary discovery. And this is where things get really weird. This is the big disagreement between theory and reality. On the left, you've got what we should see. Based on all the stars and gas we can count, Newton's laws are crystal clear. Stars on the outskirts of a galaxy should slow way, way down, just like the outer planets in our solar system move slower than the inner ones. But, as you can see on the right, that is not what happens, not even close. They keep moving incredibly fast.
And this chart just illustrates the problem perfectly. This is the real data from the Andromeda Galaxy, first measured way back in 1970 by Vera Rubin and Ken Ford. The expected speed is that steep nosedive. But the actual data points, they form this shockingly flat line. The only way you can explain this, the only way, is if the entire galaxy is sitting inside a massive, invisible halo of matter whose gravity is grabbing those outer stars and just whipping them around.
Now, this wasn't just some fluke in Andromeda. Nope. Astronomers have now looked at hundreds and hundreds of galaxies. And guess what? They all tell the exact same story. That flat rotation curve, it's everywhere. It is the cosmic fingerprint of all this missing mass. It's the calling card of dark matter.
Okay, so if this invisible stuff is really out there holding our entire universe together, what in the world could it actually be? The investigation to identify this cosmic phantom is officially on, and it's one of the biggest mysteries going.
We've got a few prime suspects lined up. First, you've got the WIMP. That stands for Weakly Interacting Massive Particle. Basically, think of it like a heavy ghost that can pass right through walls, right through you without you ever noticing. Then there's the Axion, which is an incredibly lightweight particle, so light it acts more like a constant, invisible wave filling all of space. And then there's a wilder idea, primordial black holes, ancient, tiny black holes that might have been forged in the chaos of the Big Bang itself.
The authors of our source material put it so well. They said our search for dark matter today is kind of like when ancient philosophers were just guessing what atoms were. We've got some really good ideas, we've got a ton of clues, but we are all collectively holding our breath, just waiting for that one big discovery, that eureka moment that's going to make everything finally click into place.
And that feeling has kicked off one of the biggest scientific hunts in all of human history. I mean, if dark matter really is some kind of particle, how on earth do you even begin to catch a ghost?
Well, scientists are trying three main strategies. First, they listen. They build these unbelievably sensitive detectors miles underground to shield them from cosmic rays, and they just wait, hoping to hear the faintest ping of a dark matter particle bumping into one of their atoms. Second, they look. They use massive telescopes to stare at places like the center of our galaxy, looking for a flash of energy that might happen if two dark matter particles smash into each other and annihilate. And third, they try to make it themselves by smashing particles together at insane speeds in colliders like the Large Hadron Collider.
And the result of all of this incredible effort, all of these brilliant minds and billions of dollars, so far, zip. Nothing. Nada. For decades we've been searching, and dark matter has proven to be perfectly elusive. The ghost is still on the run.
So, where does that leave us? You might think this is a dead end, but it's not.
Not at all. It actually leaves us at one of the most thrilling moments you can imagine in science. We're in what our source calls the pre-Eureka moment. I absolutely love this quote from the source material. It basically says, look, the age of exploring the Earth, of finding new continents, that's over. But does that mean the age of exploration is over? Not a chance. Physicists today are the new explorers, charting the fundamental components of reality itself. And it turns out there's a vast undiscovered continent right on that map. This graph just shows it perfectly. See that red area? That's the period of investigation before a huge discovery. You have lots of ideas swirling around, but the hard evidence is still missing. That is exactly where we are with dark matter. We're right there, at the peak, maybe right on the verge of that eureka moment that will completely transform our understanding and kick off a whole new era of physics, that green area.
And that's really the thing to take away from all this. Finding dark matter isn't just about checking a box and adding one more particle to the zoo. It's about figuring out the main ingredient in the entire cosmic recipe. It is about understanding the invisible architecture that has shaped our universe for 13.8 billion years.
Which really just leaves us with one final, pretty humbling thought. For all of human history, we've been staring out at the universe and only seeing a tiny, tiny fraction of what's actually out there. So, if we've been missing 84% of all the matter this entire time, what else are we completely blind to?